Hello everyone, greetings from India. This is Nirbhay Chauhan from Eklavya self-learning tutorials. Well, today this is not any tutorial. I will basically giving a lecture for the topic of OpenBIM and IFC. So I would like to give some details and the aims and objectives of the OpenBIM movement and something about its format named IFC. So IFC stands for Industrial Foundation Classes, and the OpenBIM. Basically, the concept of OpenBIM is to share, exchange the BIM information given by different softwares between each of them, no matter what their respective formats are. So that's why the common format IFC was formed, taking in care the open standards. So with this, no matter what software you have, whether it's commercial, free, freeware or anything else, you can share your BIM information from one software to another, therefore enhancing the interoperability. So if we see the present scenario, most of the BIM softwares, the present BIM software, they are promoting OpenBIM. No doubt they're promoting it. But if we see, are they really implementing the OpenBIM? Are they really implementing the use of open format IFC? If we see, the answer is no, because in most of the aspects for the case of IFC, they fail to export and import the essential information. Here, majority of the users and the professionals from all around the world claim that IFC is a very poor format. Most of the information is lost in that. We don't get any useful thing from that. Probably they have not seen and not understand basically the IFC. Probably they have not even opened or read the IFC documentation. I should say it's not their fault. Uh, the problem lies between, or I should say the main problem lies is due to the lack of proper guidance, I should say. So thanks to my college, my guide, Dr. HSI, due to which I came to know about many new concepts in the field of BIM and especially the Open BIM. So I will be sharing some of those key factors here, the key findings. So if we see, firstly I would like to show you a sample file from a very popular software named Autodesk Revit. I'll be showing some other files from Tekla and Allplan. All of them, those lie on the same plane, I should say, more or less same difference. So let's you let me show you a file exported by Autodesk Revit. So very firstly, I will be just showing you what actually are the main things those are not exported by the software. So IFC file is a readable file. You can read it from the notepad also. So now if you see, the very first is the header of the file. Here you can see the ISO 103-21, according to which the IFC files are defined. It's a step format basically. So now here the main game starts, where you can see all the different types of entities defined, I should say exported here, like the units. You can see the representation text, the directions, then you have the coordinates, local placement, surface styles. So at once you can say majority of the things are exported. So I can show you one example also here that I open is Solibri. So you see it's a slab model in Revit. So you see here building, levels. So here the main thing that I would like to just point out here. You can see a particular hierarchy is followed here. Like you have the site, then you have a building, then different levels, then different entities. So if you see, uh, the Revit is defining the reinforcing bar and the slab as separate entities. But what basically should happen is these reinforcing bars are the subparts of the slab. We'll know this very well. As a structural engineer, you should know the reinforcing bars are the subset of the slab. They are inside the slab. So basically, they should come under the fold of the slab. But these are independent. Therefore, one basically doesn't know where does this reinforcing bars locate or belong to. Therefore, you see most of the softwares are lagging behind the concept of OpenBIM. We don't see much of the software of the plugins which are based on the IFC. This is the main issue only, that majority of the information is not transferred by the BIM software. I don't know why they don't want to transfer the information. They are not implementing the information. So let me begin. So let me show you an example of a reinforcing bar. So you see this is entity, reinforcing bar. The very first is a global ID, then is type. So if you see on the 10th place, you have this dia 15.9. There are some software which even do not give this information. Then you have the cross section area, then you have the length of the bar, and some of the things are not defined. Let us show you the inheritance graph, the reinforcing bar from the IFC documentation. Now this documentation is like a Bible for the IFC. So this is the home page for the IFC 2x3 defined by the Building Smart. So here are the entities. Total number of entities by defined by this version are 653. So let me just show you the reinforcing bar. IFC reinforcing bar. So here's it. So if you see the inheritance graph of this, so this is an inheritance graph. The first four properties are basically about the name and the description of the entity. Then you have the fifth one, object type. This is defined here, I think. 1, 2, 3, 4, 5. So it's 3 bar. It is defined here. Then you have the object placement, representation. Then there is a tag. Then comes a steel grade. So if you see ninth place, it is probably missing from this one. Like here dollar means an indefinite character or not defined character. So you see the steel grade is not defined here. It is defined by grouping of the different rebars. So you have to just refer and refer by a group from the IFC rel associates material. That's also something improper. I'll be going to that also. So you see one of the thing is the steel grade of the individual rebar is not defined, but the IFC states the steel grade. Then you have the bar roll, that is on the 10th, 11th, 12th, 13th and 14th, which are probably not defined. So the 13th and the 14th entity are not defined by the Revit. So what will the user do? Basically, these are defined with the IFC rel enumeration. I will show you that also. IFC rel reinforcing bar role enumeration. So this is here the bar role. If you see here, you can see the IFC has defined many things like whether the bar is main, does it belong to the shear, or it's a link bar or the punching or the anchoring bar. So you see, these are many essential details. As a structure engineer, I should say, these are some of the key details for a reinforcing bar. But if you see, they are nowhere defined here. So what will the user do? That's why you say only geometric information is obtained by them. If you see the model here, it's just a geometrical information, but most of the key details are found missing. So user can do nothing here. Then uh, comes the, you can see the material details. Those are also missing. I have made down a list here, like the grouping of the rebars to the slab. So IFC has defined, one is the IFC rel aggregates, by which it defines the buildings, then the different levels. Then one more comes is the IFC rel decomposes. Let me just show you that. IFC rel decomposes. So this is here. So basically this defines that, so anything that becomes a subcomponent of a particular element, that can be defined by the IFC rel decomposes. So if you see the theoretical definition, the decomposition relationship IFC rel decomposes defines a general concept of elements be composed or decompose. The decomposition relationship denotes a whole part hierarchy with the ability to navigate from whole to the parts and vice versa. So this is also one of the major thing which is not exported or defined by the software, but the IFC is good on its part. It is very well defining the parts which are needed. Then I should say another thing that is not defined, that was the IFC material grouping. So basically what does the normal softwares do? If I'll show you IFC material here, so those are defined by the grouping. So it's just written grade 415. So it's okay, one can just judge from that. But if someone as a structure engineer, as a mechanical engineer needs some more minute details, then there are some more detailed things which are defined here, like the ISCL associates material. So I should just give you a brief overview of that, like the IFC steel properties or the IFC concrete properties. So how does the IFC define that? Let me just show you. Let me just show you for the steel. So this is the IFC mechanical properties. But if someone want to go into more further details, then these are for the concrete, IFC mechanical for the concrete details. So you see the Young's modulus, the dynamic viscosity, shear modulus for the concrete are defined, compressive strength, which is very key factor for a design engineer. Then the max magnetic size. So these are minute details which are found missing in the majority of, I should say, all of these softwares. They don't just export these properties. I don't know why they do this. Then we have the IFC mechanical steel properties. Here also the yield stress, ultimate stress. These are things which are defined by the IFC, but these are found nowhere in the IFC exported by the software. So what will the user do? This is a major reason we don't get to see the essential details. So therefore the concept of OpenBIM does not go much forward. So if someone has to just make a code compliant engine, like I am doing for my research for, there are so many difficulties found in the way. One cannot use the geometrical information for every detail. It becomes so more complex. But if the details are found and given by in accordance to the IFC, the work could be much easier. Uh, then one of the essential property that a structure engineer can, or architecture, anybody can just relate to, is like sometimes there are walls which start from a particular level and go up to the second level, third level means they are contained in a particular level, but they are referred by many levels. So let me just show example here. So that property is IFC rel reference in spatial structure. Let me just show you that entity. So here it is. So here it shows a graphical picture also. So what does it say that it just also does an example also, like while a wall might be normally contained within a story, and since it does not span through several stories, it is not referenced in any additional story. However, a curtain wall might span through several stories. In this case, it can be contained within the ground floor, but it would be referenced by all additional stories. So, like you can see, we have the site, building story, and the space. So this is a type of wall which is contained in the ground floor, but it is referred by the first floor also, then in the second floor. So these are things defined by the IFC, like the related elements and the relating structure. But unfortunately, you don't find it in the software. So there's a major, I should say, some of the essential findings. There are many more. If I just keep on counting, the lecture would be take full day. I have just given you an example from a structural point of view as a structural engineer, like how much details, the major details are found missing in accordance to the IFC. Uh, Major details are not exported, not neither given. So let me just show example slab also. If you just see IFC slab here, like we have the slab type. You see here entities, like the global entities, these are the major things. Then comes the essential ones, like the predefined type, which is not often given by the software. Then if you see, there are many types of reinforcing bar also. Generally, the software giving us only reinforcing bar, but in general, they are like many essential, like the reinforcing element, which can give you whether the particular group of rebars are transversal or are they longitudinal. They intelligently just group the things, therefore easing up the work for the structure engineer. And I can show you the reinforcement bar properties. So there are many things which are defined, like you can see here in this expert definition. Steel grade, the bar surface is also defined, like the bar count. Then there is one very interesting one, like the reinforcing mesh. It can just give you the essential days like the mesh length, the mesh width, the longitudinal bar normal diameter, then the transversal one diameter, then the cross section area also, and then the bar spacing in the longitudinal direction, the transversal direction. So see, these are some of the many essential details like a civil engineer or the design engineer would probably require to verify its design. But one does not find these details in the IFC file. Therefore, one has to just go through the geometrical information, which becomes very ambiguous, I should say, a very detailed one, and there's so much of that takes so much of time and becomes so tedious. So that's all I have to discuss for this lecture. That if we really want to just go for the open BIM, it's not just like we are just reading and exporting the IFC. The information should also be there. If a software, if a commercial software, the BIM software is exporting its information through its own native format, then it should be capable of importing and exporting as well the details to IFC also. If they, I don't know how are they getting the building smart certification if they are not relying on these standards. So what I see a good hope for the OpenBIM, uh, that is the FreeCAD. FreeCAD is the first open source BIM software. It's a free BIM software and open source. So it's a very fresh one. It's in its young age, young starting. So what I can just see in the case of FreeCAD, uh, the architecture of the FreeCAD code is quite open. Anybody can work on that. So I have a request for the developers that what they can do is they can just see the drawbacks what other BIM software are not just doing. So I think FreeCAD has got a quite good scope, a vast scope in the field of OpenBIM. They can be the first BIM software who are working uh, in a very efficient way to promote and implement the concept of OpenBIM and IFC. I see that FreeCAD can be a good one in this case. So my best wishes are for the FreeCAD. I'm not against for the commercial ones, but I should say they should also work a bit more in this direction to promote the interoperability issues, and therefore the interoperability could no more be a problem for the clients and the professionals. The ISA got a huge entities. Then comes structure analysis also, which are more or less required for the structure engineer. The not only structure engineer, the MEPs engineer, then becomes the architecture. So there can be many things or the many entities which are required. So I should say all the best for the programmers. So I should see something more to come. So I'm looking forward to give some more brief lectures in this topic of OpenBIM and IFC. Well, that's all for today. You can post your questions, the comments down below. Well, thank you so much. Thanks for watching. Goodbye.